Okay, so this is Algebra Part 2. This is just going to be solving equations today. So the previous section we saw that 4 chicks balanced with 1 chick and 24 grams. So what we have to keep in mind here is equations are all about balancing the two sides. Remember we said they're like a seesaw. So whatever's on the left for it to balance has to be the same as what's on the right. So the 4 diagrams below show that balancing can be used to solve an equation. So this is our equation, x plus 7 equals 10. Now, this is really important that you try and engage with this, and obviously the answer x is 3, but you need to do more than that because as algebra gets more complicated, we need these skills to be able to manipulate an equation. So here we have our balancing scales. We can see that x plus 7 equals 10. So I want to find out what x is, so I need to get x on its own. So basically I need to pick up this 7 here off this side of the scales. So I need to take this 7, I need to take that 7 off that side. But if I do that, my scales will topple over. So if I take 7 off that side of the scale, I have to take 7 off the other side of the scale as well. So if I take 7 away, if I have x plus 7 here, so I take the 7 away, I'm left with just x. But if I take 7 off the other side, what would I be left with? Well, I had my x plus 7 and I took 7. But to keep the scales balanced, I also had to take 7 from the other side. So I had 7, take 7, left me with x on the left. And on the right hand side, I have 10 minus 7, left me with 3. So x is on this side, 3 is on this side, so x is equal to 3. So what we say here is x equals 3 is the solution of the equation. Now this was called the balancing method, taking things from both sides. So I want to do a couple of versions here, but I'm going to do them in 2 different ways. And you can decide which way you'd like to do it yourself. So I have the equation, for example, 3x minus 5 equals 16. So I need to solve that. Oh, sorry, I have another example I want to do first, apologies. I have x plus 7 equals 16. So the first thing you got to do here is figure out how do I get x on its own. So if we were doing this balancing method, I have x plus 7 equals 16. How would I get x on its own on this side? Well, I've got this 7 here. So I've got positive 7. So to get rid of a positive 7, I'd have to put it in a negative 7. So I have my x plus 7, but I want to get rid of that 7, so I put in a minus 7. But that unbalances my scales. I just put on something new. So I have to put the exact same thing on the other side. So I have minus 7 here as well. So x plus 7 minus 7. So plus 7 and minus 7 cancel each other out, leaving me with just x. And 16 takes 7 on the other side, leaves me with 9. So x equals 9 as our solution. There's another way that lots of people do that. They have x plus 7 equals 16. And they want to get x on its own. So what they say is that they're going to bring the plus 7 over here. And when things come over the equal sign, they change their job. So this 7's job here is plussing. So when that 7 comes over, sorry, that's supposed to be 16 there. When that 7 comes over, it changes its job from plussing to minusing. And 16 minus 7 is 9. So this method on the left is called the balancing method, and this method on the right is kind of how a lot of people would learn it, how most people would learn it. When a plus 7 comes over, it becomes a minus 7. But don't think of it so much as a plus 7 becoming a minus 7. Think of it as it's changing its job. We'll do one more example. Here I have 3x minus 5 equals 16. So I'll do my balancing method first. So I want to get the x's on their own. So the first thing you get rid of is your constants, your numbers that are on their own. So I'm going to get rid of that minus 5. So to get rid of that minus 5, I'll have to put in the opposite of minus 5. And the opposite of minus 5 is plus 5. Because minus 5 plus 5 would be 0. But now I've unbalanced my scales. So if I put that plus 5 on the left, I must also put it on the right. So I have got minus 5 plus 5 here. That's 0, so that's gone. So all I have is, oopsie daisy, all I have here is 3x. And 16 plus 5 is 21. Now, I don't want 3x, I want x. So if I have 3 times x here, how would I just get x? Well, this 3 is multiplying the x. So if I wanted to turn that into 1x, I'd have to divide it by 3. 3x divided by 3 would just give me x. But if I divide the left by 3 to keep it balanced, I must divide the right by 3. So what's 3x divided into 3 parts? Well, it's just, each part is just x. 3 into 3 goes once, it's 1x. And 21 divided by 3 is 7. And lastly, I'll explain that using a kind of the more traditional method, which is how most students choose to learn it. I get rid of my minus 5 first. So minus 5 comes over and it changes its job. It changes from minusing to plussing. So it changes to plus 5. Then I tidy up. 3x equals 16 plus 5, 21. Now, what's this 3's job? What's that 3 doing? That 3 is multiplying the x. So it changes its job when it comes over from multiplying into dividing. So 21 divided by 3 is 7. Now, what's really important here is you'll notice I'm doing my maths downwards. We do not do it right to left here, or left to right even. You do it downwards, and I only ever want to see one equal sign on any line. You know who I'm talking to. Please number your questions and title your work.